this problem we have a child mini golfing. He puts a ball up a 0.25 meter slope at 30 degrees and he hits it at 4.6 meters per second, and we want to know how high it goes. So we're going to break this up into two problems. First, we'll figure out exactly the speed that it's going up the ramp. So at this point we want to know what it's going, then we can figure out exactly how high it goes using projectile motion. So we can say energy initial equals energy final, conservation of energy. So our initial energy right here, we have potential energy plus kinetic energy. This is initial equals potential energy final plus kinetic energy final. Okay, initial potential energy, mgh. Height. We're going to call our zero height at the base here. This is zero height. So we can say this is 0. Because h is 0, this whole thing is 0. Kinetic energy, 1/2 m v naught squared. We know v naught. And potential energy final, mgh, the height up here, plus 1/2 m v final squared. So we know we have 1/2 m v naught squared equals, we need to figure out what h is. H is this height here, the height the ball is at. We know this angle and that length, so we just got to say this is sine. We want this height, so 0.25 mg is 0.25 sine 30 degrees. That's our height. So this height here, if we plug in 0.25 sine 30 and just figure out what that is, because we're going to need it for later, so I'm just going to figure it out now. It is 0.125 meters. 0.125 meters is here. And we have plus 1/2 m v final squared. We're looking for v final squared. Now we have 1/2 mv squared m. We're going to divide m out of everything. We're going to have 1/2 v naught squared, which is 4.6 squared, equals 0.25 sine 30 is 0.125. 125 times g, 9.8, plus 1/2 v final squared. So solving for v final, we say v final equals, and we have 1/2 4.6 squared. So we have 4.6 squared over 2. Subtract off 9.8, 0.125, and we multiply everything by 2. And we take the square root, because what I've done is just move this over here to get this, and then taken this, multiplied by 2, taking the square root, and that will give us our final velocity of 4.3255. 4.3255 meters per second. That's right here. That's the velocity right there. Now what we have to do is we want to figure out the height here. We can do this again using conservation of energy, and we can do this in the y direction only because the energy doesn't change in the x direction. Since now that it's projectile motion, the x directed velocity is the same, so that doesn't change. So that energy stays constant the whole way through. The only thing that changes is the energy in the y direction. So we're going to do the energy initial equals energy final, y direction. So the initial energy I'm calling right there now. So we're going to say our mgh. I'm going to say this height is now 0, because it's like a second problem now. So I call this height 0. So it's 0 plus 1/2 m v naught squared. This is now my initial velocity, which is going to be the y component of this, which is equal to mgh, which is going to be this height here. So I'll call this h final. So I'll just call this h final plus 1/2 m v squared. Now since I'm doing this in the y direction, the velocity is 0. So that whole term is 0. So all I'm left for is 1/2 m. Initial velocity, let's figure that out. We have 4.3255. That's in this direction. So maybe I'll make a triangle showing this. 4.3255. Angle of 30 degrees. We want the y component. So we're going to use sine. So 1/2 m 4.3255 sine 30 squared. 1/2 mv squared equals m. G is 9.8 and HF is what we don't know. H final. And we notice I didn't put m in because it cancels out. So now all I do is divide 9.8 over here. 4.3255 sine 30 squared over 2 times 9.8 equals final height. Final height is equal to 0.2386 meters. That's this height right here. So as you can see, I drew it a little wrong. It should go a lot higher, but that's the height here. We add that to our original height we were up to get our total height. So we add 0.125 to that. It gives us a total height of 0.364 meters. Final answer.